Welcome back. In this class we are going to continue about some area capacitance calculations. Now here if you observe that I have considered a typical example, that means a multi-layer example. Now let us observe very carefully. Now here this is a metal and here you are having a polysilicon and a diffusion, okay, to form a transistor, and this metal is interacted with the polysilicon, then you may have a contact cut here. Is it understood, all of you? This is the actual picture what I have considered. Now will you please tell me how to determine the capacitance of a particular layer? Absolutely. First of all, you have to find out relative area into relative C value. Relative C value, that means relative capacitance value. Now you can observe how many layers are there in this figure. Yeah, absolutely. How many layers? 3 layers. I am considering the first layer as metal, the second layer as polysilicon, and the third layer I am considering as a transistor. Is it clear, all of you? Now you can observe very carefully here. First of all, we will talk about metal. Later we will talk about the polysilicon and the transistor. If you talk about the metal, what is the length given for metal? 100 lambda. Absolutely. Now you can observe what is the width they have given? 3 lambda. Is it clear? Now how to find out the relative area for that particular thing? Will you please tell me, anybody? Absolutely. Relative area is equals to length into width upon the standard area. What is the standard area? 2 lambda by 2 lambda. Is it clear? Now I am going to find out the relative area here. You can observe that the relative area for a metal is equals to 100 lambda into 3 lambda divided by 2 lambda into 2 lambda. Now you can observe very carefully. Lambda gets cancelled. 2 2s are 4, 4 25s. Then 25 into 3, 75. That is the relative area of the metal. Is it clear? Now you can observe very carefully. Now I am going to find out the capacitance of a metal, which is equals to the relative area. What is the relative area? 75 into then relative C value. Then we have to find out the relative C value from the table. Now we have to take the relative C value from the table of typical values of capacitance. Is it clear? Now you can observe that what is the relative value of metal. If you observe here, the relative value of metal is 0.075 standard gate capacitance. Is it clear? Now you can observe very carefully here. This value is the relative C value of the metal, 0.075 standard gate capacitance. Then after multiplying with 75 and this value, finally the metal capacitance is given as 5.625 standard gate capacitance. Is it clear? Now we have to find out one more layer. What is the one more layer we are having? Absolutely, polysilicon. Is it clear? Now you can observe that. Now you can observe the second layer. What is the second layer we have considered? Polysilicon. Now you should not consider this region in the polysilicon. Why? Because it is used to form the transistor, this diffusion and this region. Now excluding that transistor region, then you can observe very carefully what is present there. You can observe very carefully. Now this is the area you are having for polysilicon. Is it understood? And this is the area you are having for polysilicon after this area. And don't forget, here you are having a polysilicon length, here you are having a polysilicon width. Is it clear? You can have this one. First of all, try to tell here. First of all, we'll talk about this one. What is that? 4 lambda. Here we know this also what? 4 lambda. This also what? 4 lambda. Is it clear, all of you? That means you can very clear. First of all, we will talk about 4 lambda into 4 lambda. Plus. Yeah, absolutely. Try to tell what is the remaining polysilicon you are having. Yeah, you can observe very carefully. I already said that this is what 2 lambda. Okay, then this is what 1 lambda. 2 lambda plus 1 lambda is what 3 lambda. Is it clear? That is the length. Okay, what is the width of poly? Will you please tell me according to the lambda based design rule? 2 lambda. Therefore 3 lambda into 2 lambda. Is it understood, all of you? Okay, that is a very important point. Divided by what is the standard area you are having? 2 lambda into 2 lambda. Is it okay? That means you can observe that 4 is 16, 3 2 is 6. 16 plus 6, 22. Lambda into lambda, lambda square. Lambda into lambda, lambda square. Therefore, you can tell that 22 lambda square divided by 4 lambda square. Therefore, you may get cancel lambda square if can lambda square gets cancelled. Therefore, what is that? 22 divided by 4. Okay. Now, this is the relative area of polysilicon. We should multiply this relative area of polysilicon with whom? Absolutely. Relative C value. Is it clear? Now, once again I am telling that the polysilicon relative area calculation, you can observe very carefully. Okay, you should not consider the channel here. Then you can observe this area and you can observe this area, and you are having this one length and this one width. Therefore, there are two types of consideration. This we have to consider first, later plus the combination of this we have to consider. Is it clear? Now, first of all, I would like to consider this one. Now, the length is 4 lambda into the width is also 4 lambda plus. Now, and we have to consider this and this. What is this? 1 lambda, and what is this? 2 lambda. That means the length is what? 3 lambda into what is the width here? What is the width? Absolutely 2 lambda. Therefore, it is 2 lambda. Is it clear, all of you? Divided by what is the standard area? 2 lambda into 2 lambda. Is it okay? In this manner, 4 is 16 lambda square, 3 2 is 6 lambda square. Therefore, 16 lambda square plus 2 lambda, 6 lambda square, 22 lambda square divided by 4 lambda square. Lambda square gets cancelled, that is 22 by 4. Is it okay, all of you? Now, you can observe relative area we have calculated successfully here. Okay, now what is the relative C value in a sense? The relative C value, you can observe that 0.1 standard unit of gate capacitance. Is it clear? Therefore, after multiplying this, you can get the capacitance of polysilicon, that is 0.55 standard unit of gate capacitance. Okay, and finally, what is the remaining one? We are having a transistor. Therefore, we are having a transistor. Then what is the capacitance of the transistor? In a sense, 1 standard unit of gate capacitance. Then finally, what is the total capacitance of the given figure? You can observe that the metal capacitance plus poly capacitance plus the transistor capacitance. Is it clear, all of you? Or you can call it channel capacitance. Then after adding these three capacitance, you can get the total capacitance. Is it understood, all of you? Now you can observe. Okay, we know very well the value of metal capacitance is 5.625 standard unit of gate capacitance. The value of polysilicon capacitance is 0.55 standard unit of gate capacitance. Okay, the value of the channel, or you can call it as a gate capacitance or transistor capacitance, that is 1 standard unit of gate capacitance. Now the total capacitance is given as 7.20 standard unit of gate capacitance. Is it understood, all of you? Okay, now in this manner you can able to calculate some area capacitance. Okay, this is a very important topic for your external point of view, and if you are having any queries, please comment. Okay, thank you very much. Have a nice day.